2-1 relations and functions. This lesson is all about relations and functions, and specifically functions. What a function is, how to tell different types of functions, and all that good stuff. Anyway, relation. Relations are a collection of ordered pairs. It could be anything. Most times we know this as numbers, 2 and 3. I put a little parentheses there. But it can also be symbols. Triangle and box. That's actually a square. Box would be 3-dimensional, but you know, whatever. It could be stuff like here. It could be January and 32. The whole idea is it has to relate one thing to another thing. That's it. That's what makes a relation. It could be colors, blue and green. As long as you're relating one thing to another thing, it's a relation. Now, the domain of the relation is just the x values of the relation. Here's my ordered pair. We generally consider an x and a y, and all the x values are the domain. It's my domain here. We use a little curly bracket, that collection. 2, triangle, January, and blue. That'll be my domain. I like the little put x there. I know it's the x values. And the curly bracket just means it's a list. So you're saying, hey, the domain are these items here. Where the parentheses say it's a relation or this number to that number type of thing. And then if I want to range is the y value. It's a collection of the y values. The curly brackets, all the y values of the range. 3, square. I almost said box again. I was a bit mad at myself. 32 green. There you go. So those are all the domain values. Those are all the range values. And that's a relation. Now let's talk about what makes a function. A function is a relation in which every x value in the domain corresponds to exactly one value in the range. Essentially, that means all the x values are different. All x values are unique or different. If you have a relation, you want to know if it's a function or not, all you have to do is check all the x values. If they're all different, it's a function. I don't care at all about the y's right now. If I want a function, all we care about is that all the x values are different. So I go back to my relation up here. My x values are 2, triangle, January, and blue. They're all different. This is a function. Let me do a quick example. Let's look at these. Here's a relation. Even though it's not numbers, just saying, hey, this triangle goes to that reddish orb. That yellow rectangle goes to that yellow thing. So it's a relation still. If you look at these, are all different. That goes to that. That goes to that. This is a function. These are all unique. And then here's an example saying it's not a function. 1 goes to A, 2 goes to D, 3 goes to B, and 3 goes to C. So this right here is why it's not a function, because 3 gets used twice. Not a function. So again, anytime one of your x values it's used more than once, it's not a function. If I list this out, this would be 1a, it would have been 2d, 3b, and 3c. And right there, you're like, oh, I have 2 3s. A little cheater. So, not a function. Now it's a little easier to check. Listed like this. Look at all the x values. There's 2 4s. Not a function. Still a relation, just not a function. And over here, if you notice all the y's are the same, I don't care. I just care about the x values. Only that matters. And they're all different, but this is a function. That's how you tell if I give you a set of ordered pairs, or what we call a mapping function thing here, mapping relation, if it's a function or not. Next, what if I give you a graph? So if you want to tell something is a function based on a graph, you do what's called a vertical line test. So the general idea is this. You draw a vertical line. If you have to graph only one time, then you pass. So it's a function. If that line you draw it anywhere. If it's a graph more than once, it fails. And it's not a function. If you want to know why, look at this point right here. That point was, it's kind of hard to see now, but it was like 1 1 and 1, oops, I think it's 1 2 actually. That point 1 2. This point down here is 1 negative 2. If you notice, you have 2 of the same x's again. That's why it's not a function. If you draw a vertical line, you hit it more than once, that means you have the same x, but it's not a function. So let's quickly do some examples. We're just going to draw some vertical lines. Those are supposed to be straight, sorry. It's not the easiest thing to do. Each one I hit it once, no matter where I draw, you want to hit it once, so this is a function. This one right here though, that's supposed to be a straight line. You hit it twice, you know it's not a straight line exactly. This is not a function. Over here, a lot of people get confused on this one. They're not sure, is that a function or not? Well, that's what happens. If you draw a line as straight as possible, unlike me, you hit it all up and down this line right here. You have a vertical line, it's going to hit it way more than once. So it's really not a function. Over here it's fine, over there it's fine, but right here, it's not a function right there. It's not a function. And that's how you tell about graphing. Now that we know what a function is, let's talk about some special types of functions. 2 in particular. The first one's called a one-to-one function. And this is exactly what it sounds like. The definition is each element of the domain pairs to exactly one element of the range. In this case, both the x and y values are unique. Nowhere do we have 2 of the same. 1 goes to D, 2 goes to B, 3 goes to C. There's no doubles anywhere. If you have both the x and y values unique, we call that one-to-one because each x value goes to exactly one y value. And they're under different y values. Right here, this is a one-to-one function. This right here is an example of what's not a one-to-one function. It's a function. Look at all the x values. They're all different. It passes the function test. But right here, that c is going 3 and 4. But it's not a one-to-one function because there's 2 c's here. There's 3c and then there's 4c. This one's not one-to-one. C's a little two-timer. If I give you a graph, how you tell if it's one-to-one function, we can do what's called a horizontal line test. If something passes both vertical line test and horizontal line test, then it's a one-to-one function. Right here, you draw a line. You only hit it once. Exact same rule as a vertical line test. You only hit it once. and then it's a one-to-one function. So if it passes a vertical line test, it has to be a function, plus the horizontal line test, then it's a one-to-one function. Now this one right here, this does pass a vertical line test, so it is a function, but if you draw this, it doesn't pass a horizontal line test. You cross it twice, and just like before, that means you have two of the same. In this case, two of the same y's. It's not one-to-one. Again, still a function, it's not a one-to-one function. That's a one-to-one function. All the x's and all the y's are different. On the function, you only care about the x's, and a one-to-one function, you care about both. Now we have an onto function. Onto just means all the range gets used, y values. If you have a function where all the y values get used, we call that onto function. Look at here, this is a function, they're all different. And then over here, it's not one-to-one because c gets used twice, but it's all being used, but it's called onto. Very easy to tell if it's onto if I give you a mapping function. You just look, hey, are all the y values going to use? Yes. Over here, no. That c has nobody to play with. It's all alone. This one is not onto. It is a function. It's actually a one-to-one function, but it's not onto because that c has no friends. They're very easy to tell on a mapping function. That's an onto function. That's not. And look at this one right here. It's a function. It's one-to-one, and it's onto. This is a one-to-one onto function. When you put it all together, you get a one-to-one onto function. Look how pretty it looks. Let's do some examples. Same idea. I just want to know if it's a function, yes or no. If it is a function, is it onto or one-to-one? Do this first one. First thing you check, all the domain values. These are all different, but it is a function. And then look at the y values. It's not one-to-one because of this guy right here. Look at that. Hanging out both b and c. I see you. But it is onto. All this gets used. So it is an onto function. It's an onto function, not one-to-one because of q. Look at b. A gets used twice. There's AQ and AR. Anytime you see the x values get used more than once, it's not a function. AQ and AR, x values used twice. So this is not a function. Look at this one. This one gets a lot of people confused. You have A go to P, and you got C go to Q, and you got D go to Q. But you're not using B. That doesn't matter. So A, C, and D, they're all being used separately. So it is not a function. Now it's not a function because B is not getting used, so it's not. And then one right here, the final one, I guess the final one of this set. A goes to P, B goes to Q, C goes to R. It is a function again. It's all nice. They're all different. It is one-to-one. No one gets used twice here. So it is one-to-one. But it's not onto because that S right there is not getting used. Poor S. It's a one-to-one function. Now I can give it to you in different ways. I can give it to you in a graph like this. Easy way to check if it's a function or not. You can still do the vertical line test. And right here it would not pass. That's one way to do it. Or you could just list them out and do it that way. If you do that, you could probably see a little clearer. See how one gets used twice. So this is not a function. Over here, all your x's are different, but it is a function. If you notice, there's two of the same y's. It's not one-to-one. And this is one you can't tell really if it's onto or not. It looks onto, but you have no idea what the range is. Let's say function for now. I will only ask you onto functions with the mapping set. Otherwise, I'll tell you what the range is. That's it for one-to-one onto functions. Let's move on to this Dwyane Wade question. So here's our first application problem. So first, let's see. Assume the ages are the domain. They're right there. Identify the domain of the range. A. You want the age to be domain. Domain would be 24, 25, 26, and 27. The range, let's do points per game. Notice I did it 6 because I'm listing stuff out, so I always do the curly brackets when I do a list. 27.2, 27.4, 24.6, and 30.2. Done. Write a relation of these order pairs. I want to put in order pairs, 24 and 27.2, the little relation. That lets you know, hey, when it's 24, you average that many points. And I'll do 25 and 27.4, and I'll stop there because I am lazy. You get that. Done. Okay, so D, graph the relation is relational function. Actually, I don't need to graph it. I know it's a function. All the x's are different. The domain doesn't double, so it's a function. But we'll graph it to make them happy. I'm going to do a crappy graph. 24 and 27, like that. And then 25 is a little bit higher, even less than that. 26 had a down year. And then 27, he came back with a vengeance. So if let's connect the dots. So again, yes, it's a function. Passes the vertical line test. Let's move on. Okay, this part. Here they want you to graph the equation and then tell if it's a one-to-one function onto, all that good stuff. And I'm only going to give you onto because they don't give you the range. I'm only going to give you onto if it's a mapping function. It's literally just graph it to tell if it's a function, if it's one-to-one or neither. Now the way we graph this, we actually haven't learned yet. If you know how to graph this using different methods, great. As of right now in the book, we haven't learned any other method besides this. Just do what your calculator does and plug in points. I'm plugging -2, -1, 0, 1, 2. Now I'll do this fairly fast. That's 2, 8, 6, and then 1, I get -6, and then plug in 2, I get -10. And all I did was plug those numbers in. I plugged in -2 in for x. Probably should have showed this earlier. And I got 8 minus 2, which is 6, and the same for the rest. Now I want to know if it's a function and if it's one-to-one. It is a function, passes the vertical line test, and it also passes the horizontal line test. It's a one-to-one function. Y equals 3x squared. Again, we haven't learned how to graph this yet, but the default always, I'm going to say this all year, default always is make a chart. I'll plug in -1, 0, 1, because I'm lazy. Plug in -1, you square negative, you do, actually, let's go all the way to 2. You do this first, I get 1 times 3 is 3. Plug in 0, I get 0. Plug in 1, I get 3. Again, do this first. Remember, x1's go first. 4 times 3 is 12. If I graph it, it looks like that. It does pass the vertical line test. It's a function. DOT passed. But it does not pass the horizontal line test. Fail. So it's just a function, not a one-to-one function. X equals 7. I'm going to do the same thing. This is interesting. I actually can't plug any numbers for x because no matter what I do, I'm going to get 7. No matter what my y is, I can plug in 0 for y. There's nowhere to plug it in. I get 7. Plug in 13 for y. There's nowhere to plug it in. I just get 7. No matter what I put here, I get 7. All they're saying is x is always going to be 7. The way that works this, you go where 7 is on your x and just follow the tally mark. That's the graph. Now, if I do a vertical line test, it is not going to pass. We talked about before, it hits it the whole way down. This is really not a function. Did not pass a vertical line test. Okay, last thing here with functions. Let's talk about how to evaluate functions. This is one of the most ideas in all mathematics. Here we go with f of x equals -4x plus 8. Really what you want to see this as is this. It's f of space equals -4 times space minus 8. What I mean by that is whatever's in here, you plug in right there. So over here they have f of x and they have -4x. I could say, hey, what's f of triangle? And all you can do is go -4 triangle minus 8. I could say, what's f of 0? And plug 0 in for the space, and so on. So that's all it is. I don't care what I put there. All you do is plug in for the x right there. That's how a function works. In this case, I want f of -3. F of -3, plug in -3 for the x, the space where x is holding, and I get -4 times -3 is 12. 12 minus 8 is 4. And that's your answer, 4. I could write like this if I want to. My answer is just 4. It's like a sentence saying, hey, when you plug in -3, you got 4. That's my answer. Don't go and divide by negative. Don't do anything else. 4 is your answer. I want g of 5. So I want to know what happens when I plug in 5. Just plug it in. So again, I'm going to do this first. I get 25. Then I'm going to multiply by it here. I get -50. This is 20. Minus 20 plus 1, I get -70. Plus 1, I get -69. You can write like this. When you plug in 5, you get -69. But really, your answer is just that. That's how you evaluate a function. Just plug the number in. Now, let's talk about how you evaluate a function if I give you a graph, which is far more interesting. If I want to figure out what f of 2 is, this is your x value, your domain, and I want to know what the y value is. All you got to do is go to 2 on your x, right here, and then f of 2 is 1. Let me do another one. What's f of 0? Well, go to 0 on my x, go to 0, and your graph hits at, let's say, -3. If I want f of 4, again, go to 4 on your x, follow the graph. Also -3. Well, it's not a one-to-one function. Let's do it one more time right here. Let's figure out what f of 1 is real quick. That'll be the last thing I do. So again, on your x, go to 1, and then follow the graph. Where does it hit at? It's at also 1. And that's the lesson.